Okay. Looking at this question, determine an equation for the following polynomial function. So where are the zeros? 0 at -6, at -2, at 1, and at 3. So we're going to write all those down. X equals -6 is 0. X equals -2 is a 0. X equals 1 is a 0. And x equals 3 is a 0. So from that, we want to build a polynomial. Well, if x equals -6, that means x plus 6 is 0. If x equals -2, that means x plus 2 is 0. If x equals 1, that means x minus 1 is 0. If x equals 3, that means x minus 3 is 0. Now, they all look like they are multiplicity 1. Let's go back and look at the picture to make sure. If it bounces, it's multiplicity 2, but these all pierce the x-axis. Pierce, 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 pierce. So they're all multiplicity 1. Again, if it touches and bounces at the x-axis, that would be multiplicity 2. Multiplicity 3, it has to have a horizontal sort of tangent line there, a little other option. Okay, so they're all multiplicity 1. So our p of x is going to include x plus 6 to the first power, x plus 2 to the first power, x minus 1 to the first power, x minus 3 to the first power, and some multiplier. But how do we find out what that multiplier is? Well, I need a point on the graph. What did I give you? The point 0, -1. So 0, -1 seems to be on the graph. If 0, -1 is on the graph, that means -1 equals p of 0 equals a times 0 plus 6, 0 plus 2, 0 minus 1, 0 minus 3. So -1 equals a times 0 plus 6 is 6, 0 plus 2 is 2, 0 times -1 is -1, 0 times -3 is -3. So what does that look like? -1 equals a times 12 times 3, 36. Negative times negative is positive. So it looks like that is going to be 36a. So if that's the case, dividing by 36, -1 over 36 equals a. So therefore equals a. So remember, this is where we were before. So plugging the -136 then, I will get p of x equals -136 times x plus 6, x plus 2, x minus 1, x minus 3. But let's take a look at this on Desmos and see if that is what I need it to be. So I'm going to plug that in. To Desmos. So we'll erase what was there before. So now I have -136 and then I have x plus 6, x plus 2, x minus 1, x minus 3. How does that look? Does that look similar to what we had before? We have the point 0, -1. That looks good. We have zeros at 3, 3, 0, 1, 0, -2, 0, and -6, 0. How does that compare to what I had on the page? Let's take a look. I'd say that looks pretty good. If we have this similar window on Desmos, -7 to 5, -7 to 5. So let's just go ahead and adjust Desmos and see if I can get it to look virtually identical. So adjusting my window here. So -7 to 5 on x, whoops. -7 to 5 and -7 to 5. And hopefully that looks essentially the same as what we had on the paper. We'll take a look again. This high point between 4 and 5, this high point almost 1, this low point a little bit beyond -1. How does that look compared to what we had on the paper? This high point between 4 and 5, low point beyond -1, high point almost 1. I'd say that looks pretty good. So that should do it for us.